بسم الله الرحمن الرحيم. So we finished chapter 4. We talked about user authentication and key distribution. We talked about two different standards, and we talked about identity management. Chapter 5 طبعا احنا whether Kerberos or certificates, this is application level, right? So all the protocols that we talked about so far are application level. And we will use these as part of this chapter. Here, we're talking about security from the network access layer point of view. In network access is divided into two layers. اللي هما ايه؟ Data link layer and physical layer, right? Which means that network access layer is responsible for connecting devices physically. Okay? So when we talk about security in this level, we talk about how to facilitate the access to physical parts of the network. Okay? So in other words, the main idea of this chapter is that we have a specific network topology, physical network topology, not حتى logical. We talked about logical and physical, صح? When we talk about the physical network topology, we may have like a switch which connects multiple devices in multi-access, صح? And we have another switch, and we may have another Wi-Fi. Okay. Again, this Wi-Fi connects multiple devices, but in wireless, right? And you have a router here. Okay. This switch is connected. This switch is connected. This access point is connected, and so on, right? So this chapter talks about the fact or the scenario that there is one node now is coming to connect a physical port or a logical port in the case of wireless. Okay? This chapter talks about the physical port using Ethernet. In the next chapter, we'll talk about a logical port in the case of wireless. And unfortunately, security protocols are different in both cases. We'll talk about why. So here, there's a physical port that we need to connect to. So you have RJ45 cable, and you're trying to hook it up here. Maybe some of you have tried to connect RJ45 to one of these ports, and you try to work on your laptop, it doesn't work. Okay? Why? Because your laptop does not have access to physical network through this port. In other words, your physical port was not authenticated to have access to the physical network. Okay? Type. So this node now connects this physical port to the switch. So this node needs to authenticate that port. When we talk about authentication, we talked about user authentication, we talked about device authentication, right? So the authentication can happen for a user based on user ID. The authentication can happen to a device through IP address or through physical address, MAC address. Okay? Anything identifiable can have authentication, right? Type. So if this port is authenticated, this node may have access to specific physical part of the network. Could be that the access domain of this port, the authenticated port, could be one broadcast domain or one multi-access physical network. Okay? It could be a specific virtual LAN, or in other words, some logical ports that span multiple broadcast domain, but they can be contained in logical domain. We call it virtual LAN. Okay? Or it could be a big domain that contains multiple. But in all cases, it's physical part or parts of the network. Type. So that's what we are going to talk about in this chapter. Type. Based on what? So we said that when the port gets authenticated, gets access to specific part of the physical network, but based on what? Based on certain rules and policies. We call them policies. Okay? Based on certain policies. These policies could be that, okay, so in general you have access to one physical broadcast domain, okay, and one virtual LAN or multiple physical domains or something like this. But one of the policies says that if your password has not been updated or something like this, then you cannot have access to the network. Or your physical MAC address on this port does not have access to the physical network. Or if your even antivirus is not updated, you don't have access to them, and so on. So there are certain policies based on which I will give access to a particular node or a device to the physical parts of the network only if the physical port is authenticated. Okay? So first we authenticate, and then we give access to specific parts of the network based on certain policies. That's in a nutshell what we are going to talk about in this chapter, right? And remember here, network access control talks about physical, everything is physical. We talk about, it's very much topology oriented. It's very much connected to MAC addresses, physical addresses, and so on. And it can incorporate, by the way, high layer policies, like, as I said, antivirus, things like that. Okay, so we'll talk about how we group this picture in the standard. So network access control security, it's an umbrella term for managing access to the network physically, because we can have access to the network logically, right? We can have access to a server, but here we'll talk about physical topology back. ماشي? Authenticates user logging into the physical network and determines what data they can access and actions they can perform. So based on that, you can have access to a specific part of the network. So if you try مثلا to access a device outside of this domain, we will not allow you to do this. ماشي? Also examines the health of the user's computer or mobile device, as we said. So this is part of the policies. This is part of the policies. So if your antivirus is not updated, we will not give you access to the network. Okay? If you have a specific MAC address, we will not give you access to it, and so on. So this is part of the policy. Type. So this is the overall architecture. So the overall architecture here talks about a supplicant. This supplicant is the node that tries to authenticate a physical port to this network. Okay? So this happens through either an access point, wireless access point, or a physical switch where this port is physical. Okay? It's RJ45 cable, you're trying to hook it up in the physical port. Okay? So we talk about the concept of authentication server. This authentication server is the first entry point to this physical network. Okay, whether it's a switch or a Wi-Fi access point. ماشي? This is the first entry point. So you should perform authentication through this access point first before you get access to the physical network. So first, you send this access point like a low-level request that I want to connect to you, whether it's physical or through wireless. This authentication server will then ask you to perform the authentication, but this authentication requires the engagement of some back-end servers. Okay, so you ask, so you want to first you want to connect to the physical network through this access point. So the access point will tell you, okay, so you need to authenticate. Then number 3, you have to go to the back-end server or the policy server to perform that authentication. This may require the engagement of different back-end servers, okay, whether from the physical topology point of view or from the policy management point of view. So physical topology point of view, there are certain servers that maintain, like for example, DHCP server maintains IP address. Okay? So based on the policy, if your port is authenticated, then I will give you access to a specific subnet. Okay? Subnet is divided or defined by range of IP addresses. Or I give you access to a particular virtual LAN or virtual LANs. Virtual LAN is low level. It's under IP, right? You know that virtual LAN is a layer between IP and data link, right? So it may span 2 switches, right? But you have logical grouping of the ports on 2 switches or 3 switches. ماشي? And there are certain policies, okay, based on which you can admit this supplicant or this node to the physical network. Could be that your antivirus is up to date. If your antivirus is not up to date, we'll ask you to update it. Otherwise, we'll not give you access to the physical network. Okay? That your code, مثلا, patch management. So your code should be up to a certain level, and you need to update this patch or something like this, or اللي هي Windows updates ولا حاجة زي كده. Okay? So these are policies or rules based on which you get access to physical parts of the network. This physical part of the network could be using MAC address, or you have specific broadcast domain access, okay? Or it could be IP, okay? So you can have access to one switch, one broadcast domain, هو بنسميه virtual grouping of multiple switches through virtual LANs, or it could be subnet based on IP address. Okay? Once your port is authenticated, now your port is, we call it controlled. You perform the authentication, we call now that your port is controlled, which means that we have the authentication done, and your physical port now is admitted access to the physical network. So you can perform all the operations in the high level. You can connect to any resource in the network, and you can perform all your functionality, which is what we talked about, from application level, from web services, any kind of resources in the network. ماشي؟ طيب. So we call this enforcement. So network access enforcement here so the actions that are applied to the authentication requester, we call it authentication requester, اللي هو supplicant, okay, to regulate access to the enterprise network. So many vendors support multiple enforcement methods simultaneously. So in here, مثلا in QU, you have multiple levels of enforcement. So I could give you access to one physical switch, 2 physical switches, مثلا through virtual LANs, or subnet. I can give you enforcement, or I can give you access, restricted access to using any combination of these. Okay? Whether on the data link layer point of view, or on the virtual LAN point of view, or on the IP point of view. ماشي؟ طيب. As part of the data link layer, or network access layer in general, we have a standard called the IEEE 802.1x. Okay? Sometimes we call it extensible authentication protocol over LANs. Okay, we'll talk about this. So authentication before a port is assigned an IP address. So DHCP will assign an IP address eventually to your node. But as a prerequisite to this step, you have to have an authenticated port first. ماشي؟ هتقول لي I don't do this because I use my laptop wireless. Even wireless, you have to authenticate first, and that's why sometimes you connect to the wireless LAN of the university, and sometimes it doesn't work because your device was not authenticated. Why? Because you don't have access, you cannot authenticate yourself. Authentication itself, as we have discussed in previous chapter, can happen through a bunch of ways. صح? You could authenticate using user ID and password. You could authenticate using token, whatever. ماشي؟ طيب. So based on this standard, we perform the authentication in the network access layer, and based on that, you get access through virtual local area networks. So we provide like some network segmentation, اللي هو logical grouping of multiple LANs. Virtual LANs is a logical grouping of multiple LANs underneath the IP layer. So virtual LANs still use MAC address. واضح؟ ماشي؟ We did not study virtual LANs in details in network 1, but it's not something new. It's actually a logical grouping of some physical ports into one group. We call it virtual LAN. These ports might span 2 switches or 3 switches, but we still deal with these ports using MAC address. Okay? ماشي كده؟ طيب. We have, of course, the firewall which can use higher layer addresses, like we can use IP address, we can use even port number to identify applications and so on. ماشي? So we can use the firewall as well. And DHCP, which if the port is authenticated, and we'll see what are the steps to do this, then the DHCP will then assign you a specific IP address that you can use to connect to the other parts of the network. So this is the layered design. This is the layered model. We talked about the layered model in network 1 at the different layers. Here, this is the layered model from the perspective of security. ماشي? طيب. So you have the data link. ماشي? And you have this is, we call it extensible authentication protocol layer. This layer, actually, you can perceive it as, طبعا فوق data link layer we have what? Network layer, right? صح? So this you can perceive it as network and transport layer. يعني this layer spans both the network and the transport layer. So in fact, extensible authentication protocol provides a transport service, okay, to perform the authentication, okay, for this port. The authentication itself, extensible authentication protocol, it's not an authentication protocol. That's why the word is extensible. Extensible authentication protocol provides here a unified interface. Okay? A unified interface to perform the authentication. Authentication itself can be done in a bunch of different ways, but all of them can use EAP or EAP as the transport service to conduct the process of authentication. ماشي؟ Okay كده؟ So this is number 1, or this is the first transport layer to perform the authentication. The authentication method itself can be through a bunch of different protocols. Some of them we did not talk about them at all, or actually most of them for that matter. So you have transport layer security, you have tunnel transport layer security, you have pre-shared key, you have IKE version. All of these we'll talk about. So we'll talk about all these protocols. Others could be مثلا Kerberos, low application level, but Kerberos, any authentication method. Okay, we'll talk about all of these protocols later. So this extensible authentication protocol, then in the application level, you say, I want to authenticate, so you have to provide some kind of an identifier for your device or for the user. ماشي? So you have to communicate this to a back-end server so that this back-end server can give you, similar to what we studied in Kerberos. So the server can give you a challenge to tell you, okay, so here is a challenge. If your password is correct, you have to be able to solve that challenge and so on. ماشي? Then you solve that challenge and send it back and so on. So you have to negotiate, you have to do some handshaking until both of you agree that your device or the user working on this device is authenticated. ماشي? So you have to perform some messages. The number of messages and the type and the format of all these messages, they are different based on what method you use. صح? But all of them, they can use the EAP as a unified interface, okay, to send unified messages to conduct this particular authentication. ماشي? So here I have application level data, okay, which this one is based on what type of standard, whether it's TLS or SSL or PSK or IKE or whatever, صح? So we add to this اللي هو الايه EAP header encapsulation. ماشي? So this is a transport layer level. ماشي? So the EAP acts as a unified interface to all the authentication methods. Now you have the IEEE 802.1x. This standard is only valid for the case of multi-access networks. So this is for multi-access networks only. Okay, why? So we see for the case of PPP is multi-access? No, of course, you know PPP is you have two nodes. We don't call it peer-to-peer, the application level. That we call it Gonatella level. Here we call it point-to-point. Okay, peer-to-peer application level. Here we call it point-to-point because it's physical connection. ماشي? Point-to-point. PPP is point-to-point protocol. اسمه كده. Okay? Of course, for point-to-point, as we can imagine and as we discussed in Network 1, there is no big challenge. Why? From a security perspective. صح? Why? Because any message is sent from here, it will arrive to the other side, right? So the possibility of having like some eavesdropper is eliminated in that case, right? That doesn't mean that we should not perform authentication. We should still perform authentication. But in that case, for the PPP protocol, it's less challenging because it's not a broadcast domain. As we discussed in Network 1, broadcast domain is always challenging from a security perspective. Why? Because any message that you send, by default, has everybody else eavesdropping on this message. صح? So that's why we need another extra level of security for the case of multi-access. So for this case, we have what we call a IEEE 802.1x, which acts on top of data link to provide a security protocol on top of the data link layer, only for multi-access LANs, ماشي? Not for point-to-point. We call it Extensible Authentication Protocol over LANs, EOL, over LANs. LANs here refer to multi-access, right? So this is the layer design. ماشي كده? So we'll talk about the actual sequence of authentication, how we perform that authentication.
Doctor, the authentication methods are
it's the authentication method. It's agreed upon before. يعني it's agreed upon. It's something that the network analyst or the policy maker will specify. Here مثلا in the network, when you connect, whether it's a physical port or a logical port, for the first time, then you get a window that tells you you have to enter your user ID and password, صح? So you have to authenticate yourself. Once you get authenticate, once you provide your user credentials, your physical port will get authenticated, right? So in that case, you as a user, you will have access to the physical network from this particular device through that physical port. ماشي؟ Did I answer your question? واضح كده؟ تمام؟ So that's the layered model. So here you see for Ethernet طبعا is multi-access, but physical, صح? Wi-Fi is of course multi-access, but through wireless channel, صح? Both of them are multi-access, صح? This could be مثلا FDDI مثلا اللي هي fiber optics اللي هي multi-access for fiber optics. Any kind of multi-access network, you have to use IEEE 802.1x. Okay? So again, this standard is done in a way similar للlogical link control. فاكرين قلنا logical link control كانت agnostic to the physical technology itself. Okay? يعني it doesn't matter whether you're using fiber optics or cable ولا. So 802.1x is designed using the same perception. It doesn't have anything to do with the physical cable, okay? But it's required to facilitate the security authentication in multi-access lanes. واضح كده? Any questions? So this is the layered design. Talk about the authentication methods. EAP itself provides, or EAP provides, a generic transport service for the exchange of authentication information. It is on its own, it's not an authentication protocol. يعني it's not an authentication method itself. It does not provide an authentication method. ماشي? But it provides a unified interface to whatever authentication method that you want to use. يعني as we said here, we use user ID and password. Okay? To use similar to Kerberos مثلا. Maybe in other lands we can perform authentication similar to IPsec مثلا. اللي هو IKE standards. This is part of IPsec. We'll study it. ماشي? You can use pre-shared key, so you may actually have your private key as a file and you can upload it or something like this. So whatever method you use for the authentication, it works on top of EAP. ماشي? The basic EAP transport service is extended by using a specific authentication protocol بقى. اللي هو whether it's TLS or TTLS or pre-shared key or IKE or Kerberos or whatever. ماشي? So these are the possible authentication methods بقى, which can work on top of the extensible authentication protocol. You have transport layer security. Okay, from the name, it's in the it uses some mechanism in the transport layer. You have the tunneled transport layer security. We'll study that. Generalized pre-shared key. Pre-shared key is a symmetric key. So you want to perform authentication to share a symmetric key. Okay? Or IKE, which is part of IPsec. Part of IP security. We'll talk about this. Okay? So the standards, the standard itself, the EAP specifications, it's a standard, صح? It's a unified interface. It's a standard, right? So the specification defines certain terminology. ماشي? Certain terminology that facilitates the exchange of authentication messages regardless of any method you use. ماشي? So you have certain terminology. You have the EAP peer or EAP peer. This peer is the one that wants to conduct the authentication. اللي هو basically it's a process that runs on your laptop. So whenever you get the port and you want to hook it up physically to the network, this is what we call the EAP peer. Your laptop now acts as an EAP peer. Okay? It wants to perform the authentication. And there is the EAP authenticator. EAP authenticator اللي هو authentication. Remember we talked about authentication server? So the EAP authenticator is the one that requests or is the entry point, like the Wi-Fi access point or the switch. طبعا when you hook up to a physical port like this one is connected to a switch. So the switch or this access point will act as a EAP authenticator بقى. ماشي? This is the one through which you perform the authentication. طيب. This authenticator, which acts as an access point, it runs on the network authentication server that requires EAP authentication prior to granting access to a network. ماشي? So you say, I want to connect to the physical network. So the access point or the switch will tell you, okay, if you want to get physical access to the network, please, you have to conduct the authentication. And I can give you مثلا you have to conduct the authentication through this server. اللي هو back end server. ماشي? And you need to do this using method مثلا pre-shared key or using مثلا TTLS ولا حاجة زي كده. ماشي? Based on that, you say, okay, so I want to authenticate back, then I will have to connect to the authentication server, which is a back-end server. This is not the access point. The authentication server in that case is a back-end server. ماشي? This back-end server is the one that maintains all the access control for any user or any device. ماشي? This authentication server بقى is a server, it's a back-end server, ماشي? Negotiates the use of a specific EAP method with the EAP peer. But everything has to be tunneled through the access point or through the switch. يعني بمعنى أصح you want to access the physical network, so the access point will tell you, okay, you need to connect to the backend server and perform the authentication. And by the way, I'm going to be in the loop and everything is going to go through me. ماشي? All the messages back and forth is going to go through me. Because the access point is your entry point to the physical network. There is no other point خلاص. ماشي؟ ماشي؟ طيب. How do you access the back-end server? We talked about if we're talking to the access point or to a physical switch, then we have to use اللي هو 802.1x because it's a multi-access network. If you want to talk to one node only using point-to-point, then you don't need 802.1x, صح? You can على طول send EAP messages to that particular node directly without having any other protocol in the middle. واضح كده؟ طيب. When I talk to the access point will I talk using 802.1x, صح? These messages 802.1x will be sent to the back-end server. ماشي? From the data link point of view, this uses a protocol called radius. ماشي? Radius ده it works underneath the EAP. We'll see now how we'll see in the big picture how it looks like. So this is called remote authentication dial-in service. So the name is very old, by the way. Why? Because زمان يعني we used to authenticate through calling a phone number. You didn't live these days. You're so young for this. So we used to, and ونسمع بقى التون اللي هو الفويس تون ده. Search كده على اليوتيوب يعني because you're not familiar with this. يعني if I have my son مثلا listening to this, he would be يعني. But we live these days يعني. We used to call a number مثلا to أريدو مثلا ولا حاجة زي كده, to have access to the physical network of أريدو, and we hear like a tone, and when we hear this tone it looks very weird, but we're very happy because we are used this tone, يعني it means everything is good. So these are the old days, but unfortunately the protocol name got stuck. So until now they use a protocol called Radius, although of course it's not using phones, it's not using dial-up anymore. This is how, again, the layers looks like, and what are the protocols that interact. So in the layered model, we talked about this part, right? We talked about EAP, and underneath EAP we have 802.1x, okay? Or PPP directly. So in that case, we tunnel the EAP messages either through 802.1x for the case of multi-access networks. ماشي? For the case of PPP, خلاص, we don't need to use 802.1x, we use PPP directly. We don't need any extra protocols for this, right? So the EAP messages themselves, they go through the authenticator, right? اللي هو access point. We call them pass-through messages. Pass-through messages. It's like مثلا it's like TCP messages, they go through the router, صح? But does the router process the TCP header? No, صح? The router does not process the TCP header. Similarly, access authenticator, the EAP authenticator, it receives all the messages for EAP messages for authentication, but it does not process the EAP header itself, but they go through it.
And it doesn't stop at the authenticator and then send to the other one, or does it just look at it while it's passing through?
It doesn't even look at it, doesn't process it. It's like مثلا when the router receives a message, what does it process? The IP header. Does it process TCP? No. So the EAP authenticator will process the 802.1x header because it's multi-access, right? But it will not process the EAP header. It doesn't look at it. ماشي؟ عشان كده we call the EAP messages pass-through messages. But any higher level protocol, it needs some kind of low level protocol from the data link layer point of view, the one that deals with physical addresses and so on, right? So the EAP messages will be tunneled through 802.1x to reach to the authenticator. The authenticator will do what? Will do decapsulation, will read 802.1x header, process it, right? And then it will not process the EAP header, طبعا. And then it re-encapsulates these messages into another low-level message, and in that case it would add the radius header.
So it doesn't check for anything,
it doesn't check for any higher layer issues or مثلا EAP header. It doesn't check for that. But it needs to also, so it similar to any other networking device, it decapsulates, processes the header, and then re-encapsulates to send to the next device.
But if there's a lower layer issue, would it stop the EAP message, or?
Of course.
So would the first thing be?
Yeah, مثلا if this link مثلا physically is disconnected مثلا, خلاص will not send anything. If there is any physical issue to this physical port to connect the EAP authenticator to the back-end server, خلاص, what can I do? ماشي? But assuming that this is so this is physical topology, ماشي? Assuming that the physical topology is working well, these messages for me is passed through. I don't process the EAP header. I just let it go. ماشي؟ Okay كده؟ طيب. So now بقى next we need to see بقى how. طبعا احنا what's not in this picture is the method by itself. This method is application level بقى. اللي هي what is the authentication method, whether it's بقى TLS ولا TTLS ولا pre-shared key ولا whatever. Okay. So now we need to send the application level messages using EAP header, and then using for multi-access using the 802.1x header underneath. ماشي؟ طيب. So the EAP message itself as a format is rather simple يعني. So you have the EAP messages itself. It's basically you have a code. So you have message code. This message code refers to the fact that whether this is a request or a response. ماشي؟ A request or a response. And طبعا of course the authenticator or this EAP authenticator or the access point will send مثلا a request to the EAP peer, or the EAP peer will send a request to the backend server, ماشي? And it will get a response. So you have request response. It's not one request and one response and that's it, because the as part of the authentication, maybe you have multiple steps. Okay? So you send your ID, the backend server will send you back a challenge, you solve the challenge and you send it, then it tells you, okay, your solution is correct, something like that, right? So you have to perform multiple steps until the authentication is done. EAP itself, the EAP as a standard, it does not dictate certain number of steps. All it does is just to say a request and response. And in the response, you have a code which tells you whether this is a success or failure. A response with success or a response with failure. Of course, if any of the responses they have failure, this means that the whole authentication process got halted. خلاص. ماشي? So the idea is that all the responses have to have success, okay, until the authentication process is done. If the authentication process is done, now you have an authenticated port and you can go on. Okay? And there is an identifier. This identifier, when you send a request, you have to send an identifier, like a sequence number. Why? Because when you send a response, you have to specify this response is for this particular request. Why? Because you may actually receive multiple requests from multiple devices at the same time. It's asynchronous. يعني it doesn't process one request at a time. ماشي? So when you send a response, you have to say that this response is for that particular request. So the this identifier sort of associates the response with a particular request. ماشي? Because it's asynchronous. In general, it's asynchronous communication. And the length here indicates the length to the EAP message, to the header of the message, and the application level data. So you have this is the data message, which usually it has like a type field. We'll talk about this. This type field refers to the authentication method. And then you have the actual data message, which contains either user ID and password, token, whatever. ماشي? Then you have, this is the EAP header, and this EAP header has the length field. And this length field refers to the size of this entire message. ماشي? And so you have a length field, and you have identifier, ID, and you have a code. Okay? Those are the most important three fields in this message. You have the code, you have the identifier, and you have length, and then the data. The data part itself contains as you say here, a type subfield, which indicates the method. The method اللي هي IKE, TLS, whatever. So you have type subfield, and you have the actual data. So this is the protocol data message for EAP to work with any method, okay? Which part is dependent on the method only this part. Only this part. This part is dependent on which authentication method you use, whether it's TLS or ITR or pre-shared key or whatever. The rest is agnostic. ماشي؟
Also type.
The type itself, the type as a field contains the method. ماشي؟ But the type subfield itself is the same. ماشي؟ The format is the same. ماشي؟ This data format بقى is different from one authentication method to another. واضح كده؟ ماشي كده؟ طيب, so this is خلاص خلينا نقف هنا.